So two lines are parallel. Two lines are parallel if, and this is one of those like fill in the blank questions that you would see if, and then the answer is same slope. Now you can put some more words around it, but they have to have the same slope. And if you remember,
Okay.
slope is rise over run. It is also that equation that we talked about, but they have to have the same slope. If they're just the tiniest bit different, they will eventually intersect.
Rise over run. So two planes are parallel with same slope.
Yes. So let me share my screen here. I want to show you, I'm going to show you, I'm sure, a different screen. I want you to see this because I think that sometimes we don't give this enough attention. So I'm gonna share this other screen, which is the Desmos calculator. So let's say we have the equation y equals x plus 1. And then we have the equation y, and actually, let me make it very clear. This is 1x plus 1. And let's make the slope just slightly different. 1.0001x minus 1. Now, in this view, do the lines look parallel?
The lines, they're parallel.
They look parallel, right? But if we change the window, so watch this here. We're going to go 0 to, oh boy, we got to go way out there. Went a little too far. There we go. One more. And then we're going to change the y-axis here. Okay. They actually do intersect here. Let me see if I can get that point. Do you see how the lines sort of appear like they're converging on each other? Maybe it's still too hard to see. Let me change. Let me change this to another number here. So these actually converge. I guess maybe I don't have the. So do you see how the blue line is under the red line?
Is under the red line.
The blue line is under the red line. Do you see that?
Yeah.
Okay. So if we go out far enough, though, and that's kind of the trick here, is to go out far enough. If we got 20,000, let me go out another. Let me go 20,000. So if we were to zoom in, we should eventually see that the blue, and they're getting really close together here. They're actually getting closer together. We still don't have that intersection point. Let me back this off slightly. Do you see now that the blue is above the red?
Yeah. It's above the red.
Right. And if we go back down here, the blue is below the red. If we go back to the original, the blue is below the red. But if we just change our view just a tiny bit here, let me go out. That actually was enough to see this. I'm trying to get you to see is that the blue eventually switches positions. The blue actually ends up being on top of the red. Let's see if I can find it way out here. Okay, so there it is. Do you see how that blue is now on top of the red? So the point is, and I guess I'm maybe spending too much time here trying to figure this to show you this, but they can look parallel, but it really comes down to the slope. Okay. All right, so let me go back to the other screen here, and we'll get into the kind of the geometry component of the math today. So let's say, so here's the common problem you're going to see. So you're going to have a line, and you're going to have another line. Okay, and this symbol right here, these little sort of this arrow here, this means that the lines are parallel. So this symbol means parallel. So even if they're not drawn parallel or they're, they don't look at, if you see this symbol, they are parallel. Okay. So this is considered line 1, and this is considered line 2. Now this is the new, and this is the geometry part. So this is a third line. This is line 3. Okay. And it's given a special name. It's called a transversal. Okay. So you have two parallel lines, and then it's cut by a transversal. So let's just do this one more time. So here are two parallel lines, and I'm telling you they're parallel. I'm drawing that symbol. These two lines are parallel, and then I cut them. I cut them with what's called a transversal.
The transversal parallel lines.
Transversal, yeah. And so you're going to do a number of problems with transversals in geometry. All right. Okay, so there's actually three regions here. So let me sort of do that in red here. There is region 1. So this is all region 1 up here. Then there's this region 2, which is in the center or the interior. And then there's what's called region 3. So you can think of it as you've got a part above one of the parallel lines, below the parallel lines, and then between the parallel lines. You see that?
Yeah.
Okay, now why is this important? Well, we're going to do some problems today, and we're going to talk about some angle measures. So here's a parallel line, here's a parallel line, they're parallel. They're cut by this angle right here. And I'm going to tell you that this angle right here is 70 degrees. That's this angle right here. It's 70 degrees, roughly.
Okay.
Okay. Do you have any idea how to come up with the angle measure over here? To the left here. Let's call it X.
Okay. Oh, wait a minute. This is like counterclockwise.
Yeah, it kind of is. You're going this way and
So
going all the
70
way around.
degrees is over to 100 degrees.
So in a straight line, so we're gonna just back off this just a little bit here. So if I give you a straight line like this, boy, that's not very straight. We'll come back to that problem. If I give you a straight line and you go, like you said, counterclockwise, this is 180 degrees.
Okay.
Okay, so if you go straight vertical, this is 90 degrees, and then this other angle is also 90 degrees. What do these two add up to? What is 90 plus 90?
180.
180. It has to be, because the whole thing, what's called a straight angle,
The straight angles.
is
Yeah.
180 degrees.
It
Or a
can
line.
angle. Can types of angle. So can angles be in geometry in 10th grade?
Yes.
Okay.
Yes, you'll see this probably in September. You'll see it.
Okay.
So now, what again? Like you might be thinking, well, why does this matter? Well, let's say I tell you that this angle right here is 45 degrees, and I want to know this other angle. Well, what do the two angles have to add up to for a straight line? What do the two angles have to add up to? We just did it in the previous problem. What do these two angles up here add up to?
Two angles add up to 180.
180. So these two angles down here must also add up to 180 degrees.
Yeah.
So to solve this equation, you drop the degrees and you subtract 45 from both sides. What is 180 minus 45, Sourish?
Okay. I'm thinking.
You are welcome to use a calculator if you think it will help.
$135.
135. All right, very good. So now let's do another problem. So here's another straight line. This is a straight angle. Let's say that I tell you that this angle right here is 140 degrees and I want the value of X. Well, what do 140 degrees plus X degrees have to add up to?
Have to add up to?
Yes, what do these two angles have to add up to for a straight angle?
45.
Okay, but that
No,
means
90.
okay, let's go back to the previous problem. What do the two angles have to add up to in the previous problem here? Let's go back and look. What did X and 45 degrees add up to?
180.
180. How about in the previous problem? What do 90 and 90 add up to?
180.
So a straight angle is how many degrees?
180 degrees.
Okay, can you solve this for X, please? I'm going to step away for 30 seconds. Hey, Sourish, do you have an answer for me?
Okay, yeah,
what is the value of X?
okay. I think I know the answer. I think I know the answer. It's 40 degrees.
That's right. You drop the degree symbols and you subtract 140 from both sides, and X is 40 degrees.
Mhm.
Fantastic. Okay, so let's go back to the problem that we were working on. And I'm going to actually just bring it down because we don't have enough room to work there. Okay, so what I was trying to show you here in this picture is that there's a 70-degree angle here, and then there's an X degree angle. What do these two angles have to add up to?
To 180 degrees.
That's right. So X
Okay.
degrees plus 7 degrees equals 180 degrees. So can you solve that for X, please?
Yeah. 110.
110. So rather than actually, let me just replace it here. So this is now 110 degrees. So now I'm going to put the variable Y here. Do you see that 110 and Y are on the same straight line here?
Yeah.
So that means they must also add up to 180 degrees.
Yeah.
Can you solve that for Y?
Okay. So for that right there, you have to subtract. You have to add. You have to, okay. I think I remember now. Okay. That's gonna be 70.
Y is 70, yes. So I'm going to replace that here in our picture. That's 70 degrees. Now let's call this angle over here Z. And again, like you can look at this straight line that I'm showing, 70 plus Z degrees has to also equal 180.
Mm-hmm. Okay.
So
That's
what is this angle measure here for Z?
for Z.
Yes,
110.
110. So now
I got it right.
Yes. So now what do you notice about
What?
what do you notice about the angles here? Which ones are the same in this picture?
Both of them are the same.
Yes. So if I were to draw like these are the same, and then I'm going to grab a different color here. These are the same as well. Good.
Mm-hmm. Okay.
All right. So now I'm going to come down here and draw a new image, and we're gonna talk about what we just did there. So here are two lines. Let's call this angle X. And from our previous picture, we know that this angle is also X. Meaning like whatever the number is here, this is also the number, same number there. And if this is y degrees, then this angle on the right is also y degrees.
Yeah.
And this is what is called, these are what are called vertical angles. And vertical angles are congruent.
Yeah. Okay.
And the point is that this angle is the same as this angle. And then this angle on the right is equal to this angle on the left.
Okay. So it's vertical angles that are congruent.
Congruent, yeah, that means they're equal.
Yep. Because they're the same. That's why. Okay.
Good.
So
Okay, so let's go back to our picture here.
what
So
is the
here,
lesson called, by the way, for that?
we're just doing some angle problems, vertical angles, two lines cut by a transversal.
Okay.
So let's do this again. Let's say this is 75 degrees. The number over here plus 75 has to add up to 180. So what number goes here? What number plus 75? So we can call it X for the moment. X plus 75 equals 180.
Yeah. X plus 70 equals 180.
Yes. So what is the value of X? What is this angle over here? I'm asking you to tell me this angle measure right here, Sourish.
The angle measure right there.
Yes.
Okay. So the angle measure right there, that's going to be 100. Wait a minute. Hold on. 115.
Try again.
Oh, wait, 105.
105. So this angle that's to the left here is 105 degrees. Okay. Now vertical angles says that 75 is the same as this one here. This is also 75 degrees. What does this angle measure here? It has to be the same as this other angle measure.
Yeah.
Okay. I'm going to pull up some practice problems for us to look at now and see if we can work on them together. I guess we can't quite do those yet. All right. So there's a bit more. Okay.
Yeah.
So I want you to just believe this for the moment and not, and it'd be okay to question me, but let's just go with it. This angle down here is 75 degrees also. So this one's 75 degrees and this one is also 75 degrees. So can you tell me the angle measure over here on the left? If this one on the right is 75 degrees.
Okay. 75 and 75, that's 105. And they're the same.
This one is 105 degrees, yes. Okay. Now, how about this one in the lower left? What about this one down here?
The one right down there,
Yes.
75.
75. And how about the one here on the right?
105.
Very good. Okay. Fantastic. So I'm going to grab a practice problem here and we're going to try working through this one together. All right. So the angle that is 67 degrees is this one that I'm sort of showing here. Let me actually do it in another color. I think that could help here. This is the angle that's 67 degrees. Okay. Here are your two parallel lines. These are the ones that are parallel, these two. Okay. So can you tell me this angle measure either here, here, or here? Any of those I'd like to know, either sort of this one just to its left, the one across from it, one over here. Can you tell me the angle measure of any of those, please?
Okay, the angle measure. Okay, for both 67 and 1.
No, the ones I'm circling, Sourish. These angles in here, any of these three.
And it needs to equal to 180, right?
Some of them do. Like if it were me, I would tell you to find this one on the left here or this one down here below.
Yeah. $113.
Yes. So this one down here is 113 degrees.
Yep.
What about this one up here?
113.
Is also 113 degrees. And how about the one across from it? The
67.
67. Very good. Okay.
Yeah, that's very easy. That's harder, right?
Well, you want to do this fast, which is what you did. So now this angle 1 corresponds to this angle. This is what it's called, corresponding.
Corresponding.
Yes. So this angle 1 down here is also 67 degrees. And then that means the angle above it is 113. This one's 113 and this one is 67. So notice in the problems we've done, we did this problem here. We just did a previous one. There's only 2 numbers in the entire problem. Do you see that? Like you get one of the numbers and you can find all the others, but it's either the same or it's another number.
Okay. So now these are all the same and that equals okay.
Okay, so let's look at another problem here. Grab it here. Okay. So the way these problems work, Sourish, and I'm gonna snip another one in here, is there's only 2 answers. The answer is it's either 142 degrees or it's 38 degrees.
Okay.
Because in all the problems we've done, it's one or the other. Like this angle over here is 38 degrees. This one up here is 142 degrees. This one in this position is 38 degrees. Do you see how they have to continuously add up to 180?
Okay.
Good. So then when it comes to this transversal that's cutting these 2 parallel lines, this 142 corresponds to the X, but it also continues that the 2 angles have to add up to 180. See how this 142 and 38 add up to 180. And then if you put a 38 degrees there, it also adds up to 180. And then this J would be 142 because these 2 have to add up to 180. And this is 38 degrees because these have to add up to 180.
Okay.
So my point is that there's only 2 answers. You can only, it's either one number or the other.
Okay.
All right, let me just throw a problem at you on your own here. and see if you can work this one out. So I'll give you a couple minutes here to work on that. And I'm trying to have you come up with this angle measure there.
That angle measure there?
Yep. What is the angle right there? That angle measure.
111.
Okay. So let's say.
You have to add to 180.
Right. But there's two answers, Sourish. I mean, I don't want you to just blurt it out. I mean, it's either 111 or it's 69 degrees. And if you just say one or the other, I know you're guessing. You've got to, you've really got to find all the other angles.
69, it's 69.
Well, it's one or the other. It's like true, false, right? You can guess.
Yeah.
And you get it right half the time.
Yeah.
So let's say you could end the lesson right now if you gave me the right answer. Which one would you pick?
All right. I would pick that it's A.
Okay. So I think the point here is that it's not just, we don't want to guess. We want to try and work through it a little bit more. Okay. So let's go to, we got to go do a little review on a related topic to go much further on this. So we're going to go back to solving two-step equations.
Yeah.
Two-step, and then we want to do some multi-step equations. So let's say it's 5x minus 10 equals 180. How would you solve this two-step equation? What are the two steps to solve this equation?
Okay. So, wait, two-step equations. All right. 5x
Yes.
minus 10. Okay. 10 is going to be adding.
Okay, you're going to add
a 10 plus 5.
You're going to add 10 to both sides of the equation.
Yeah, that is going to be negative 10 plus 10, right?
Yes. And it cancels out.
It's 0, and 180 plus 10 is 190.
Okay, so now what's the second step?
Subtraction. 5x minus 5.
Your 5 is multiplying the x, though.
Multiplying. Okay.
So how do you undo multiplication?
Addition.
No. Nope. Try again.
Division.
Yes, you divide. So you divide both sides by 5. Can you tell me the value of x, please?
I'm thinking. $38.
So your answer is 38. That is correct. Very good. Okay, let's solve another two-step equation. Let's say I tell you that it is 6x. This time we're going to equal 90, and let's go plus 12. Yeah. 6x plus 12 equals 90. So this is a two-step equation. What is the first step to solving it?
Okay, 6x plus. Okay, 12 is gonna be plus 12 is gonna be multiple of subtraction.
Okay, so the first thing you do is subtract. What are you going to subtract from both sides of the equation?
12.
Okay, very good. So on the left, it's 6x equals, what is 90 minus 12?
90. Okay, 90 minus 12. 78.
Okay, now what is the next step?
The next step is to divide.
Okay, what are you going to divide by?
6 divided by over the 90, and that is going to be 15.
Try again.
Wait, what? No. Is that 15 times 6? It's 15.
15 times 6. So that's the same as like 10
Oh,
times
wait a
6
minute.
and 5
Okay.
times 6.
Sorry about that.
60 and 30 gives you 90.
$13.
It is 13. Very good. Okay, let's try one more. Then we'll get back to some geometry. Let's go 7x plus 26 equals 180. I'd like you to try solving this on your own, please.
Okay. $22.
That is correct. You subtract 26 from both sides, and you get 7x equals 154. Divide both sides by 7, and x equals 22. Perfect. Okay, so the reason we're doing this is I'm going to give you a problem here at some point where I tell you that this is 30 degrees, and this is 10x degrees. And you're going to say, oh, 10x degrees plus 30 degrees equals, what is the angle measure in a straight line?
Yeah.
What, I'm asking you, what is the angle measure?
40.
Nope. What do the angles have to add up to in a straight line?
To 180.
180. Very good. So now you can drop the degrees and you can solve the equation. So you know to subtract 30 from both sides of the equation. 10x equals 150, divide by 10, and x equals 15. Okay, let's try another one here. Let's say I give you a problem like this, where I tell you that this over here is 10x plus 100 degrees. And then you already know that this is 70 degrees. What do these two have to add up to, these two angle measures?
One 180.
Yes. So, well, if you can't tell, what I'm trying to do in today's lesson is get you to always see that they add up to 180. So I'm just adding 170 together here to get 180. What is the next step, Sourish, in solving this question? What do we need to undo next? The 170 or the 10?
Okay. So what?
What's the next thing to do here to solve this? Do you undo the 170 or undo the 10?
Undo 170.
You subtract 170 from both sides of the equation. So 10x equals 10. And then you divide both sides by 10. And x equals 1.
And for 10 right there, it equals 1. And oh, wait a minute. I think you have to undo 170, right?
We already did that up here.
Okay. Okay, so, and it's good. Okay.
Great. So today we covered parallel lines. We covered cutting those parallel lines of the transversal. And then we talked about when you have a straight line, the two angle measures have to add up to 180.
Yeah. Okay.
So that does take us to the end of our lesson for today, Sourish. We are all done. We covered everything that we needed to cover. So thank you very much for letting me help you today.
Yeah.
We'll continue next week working on some more geometry concepts. And I hope you have a great weekend.
Yep.
All right. See you next time.
Yep. Have a great weekend.
You too. Bye now.
Bye. Thank you.